matrix multiplication, and then we're going to start the, I'm going to go slightly quickly through this one. Even out, I'll just go in the wrong face. So we're going to have two matrices. Oops, I'm going to mark this so I know where to start the video. So we have two matrices. So we're going to have section matrix multiplication. So here, we're going to have matrix A and matrix B, let them be matrices, where the dimension is n by n, and the dimension of B is n by k, and the resulting matrix is n by k. So basically, and then you're going to follow this algorithm right here. I usually just do it with my fingers. It's kind of hard to show you what I'm doing with my fingers. Actually, I still do. I still do it with my fingers. Basically, you're just going to take the, you're basically going to take the ith row of A by the jth column and entry by entry and add them up. That's kind of what you do. So you go over a row and down a column, and you just multiply them out, add them up, and to get to the answer. So we'll show you how to do this, and I'll show you a couple of tricks to make sure you're allowed to do what you need to do. So let's do this. So let's just write out A. A is the following matrix. It's the same thing. I didn't change it because I don't think I did. 0, 1, 0, 3, minus 2, 6. And then we're going to multiply this by B. So 1, negative 1, 2, 3. And notice right here, matrix multiplication, these are not the same size, and yet we can multiply them. But we'll do stuff which, if I try to multiply A by C, I actually cannot do that, right? Even though they are the same size. And so what you need to do here is, this has 3 rows by 2 columns, right? And this has 2 columns by 2, or 2 rows by 2 columns, right? So this is a 3 by 2, so 3 rows, 2 columns, right? This is a 2 by 2, 2 rows by 2 columns, and you just need to make sure these match. So these need to be the same. If it's the same, you can go ahead and proceed, right? If not, you just say it's undefined, right? And then this will be the resulting. So this is your result will be a 3 by 2. Okay. And before we even do this, let me show you B times C real quick. So if I type in and try to do B times C, and the reason I'm going to do that is because I want to make sure I have room. Now this is a 2 by 2 times a 2 by 3. Nope, 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 nope. It's a 3 by 2. Notice how these don't match. So this is undefined. Okay, so these are not the same. So the second it's not the same, you just say undefined, you're done. Okay. All right, so let me actually do this entry right here. So I'm going to do some entry in the middle on purpose. So here, I'm going to go by this. In order to figure out what this entry is, I'm going to multiply the second row by the first column. And so for this entry, I'm going to say box is equal to, and then I'll actually fill in the number. So it's going to be 0, first entry here times this. So 0 times 1 plus, notice what I'm doing here. I'm doing exactly what's from up here. 3 times, and I go down by 2. So 3 times 2. So this is 0. This is I. 3 times 2, let's not finish it in our heads. 3 times 2 is 6. So I have 0 plus 6 is equal to 6, and that's what goes in this box. Okay. Let's go ahead and try this one. So let's just do the very first entry. So the first entry here would be 1 times 1, which is 1. 0 times 2, which of course would be 0. So 1 plus 0 is 1. We'll do the next one here. So we'll do this entry. So it'll be the first row here times, so let me just do this in. So it'll be this row multiplied by this will get us this slot right here. Okay. And so when we do that, oops, go ahead and rewrite that one. So when we do that, we'll have 1 times negative 1, which is negative 1, 0 times 3, so this is minus 1. So once again, let me do this in red. I'm going to take these and I'm multiplying it by those. So this times this gives me negative 1, plus this times this, which is 0, so this is that. Okay? I'll get rid of that. And then here we'll do this again. So for this one, we're going to do the second row by the second column. So 0 times -1 is 0. 3 times 3 is 9. Then I'll just go ahead and finish this out for you. So we'll have -2 times 1 gives us -2 plus 6. Let's look more like a 6. 6 times 2 is 12. So 12 minus 2 is 10. And then we'll have -2 times this, which will give us +2, plus 18, which gives us 20. All right. So do me a favor. If I do all of them for you, you won't learn anything. And so go ahead and tell me what is, so go ahead and do these. B times D and then D times B. And then tell me what you get. So 1 minus 1, 2, 3, 3, 0, minus 4, 4. And then here we'll have 3, 0, minus 4, 4. And then 1, -1, 0, and 3. All right, so go ahead and give these two a try. Notice here these are 2x2s by 2x2s. And so not only do these work, they'll also give you 2x2. So you should have a 2x2 on the end of these. So go ahead and crunch through those without me real quick. And once you have an answer, go ahead and type it into chat and I will show you how to write stuff into chat. So how to write this in matrix form. You're going to type it like this. So you write an answer. So if I was going to write an answer, that's how you write it out. And I'm going to show you how to do this in Wolfram Alpha once you guys produce. Actually, just do B, and then I'll have us do D in Wolfram Alpha. So do B, and we'll do D in Wolfram Alpha. And once we have a couple of people give an answer, we will I should do this live with you. All right, so I got one person give an answer. I got the same. Fair enough. Same. All right, guys. So let's do this in Wolfram Alpha. I'll give you a hint. Usually if I write something in chat, it might be right. So let's just do this quickly in Wolfram Alpha. So here we're just going to hit bracket, bracket, and you're going to hit 1, comma, -1. And then here it's comma, it'll be 2, comma, 3, bracket. And so, and then we're going to multiply that by bracket, 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 3, comma, 0, comma, 0, 0. Oops, nope, not 2 brackets yet. -4, comma, 4, bracket, bracket. All right, and we'll just have a crunch through. And so this is how you type it into a computer algebra system, and notice what we get here. So we get the answer we got. So let's just write that one down. So here we have 7 minus 4, -6, 12. And let's just do the -6 real quick. So it'd be 2 times 3. So let's just do this one real quick. I'll do this one so I haven't, so it'd be 2 times 3 plus 3 times a -4. So this gives me -12, right? This gives me +6. +6 plus 12, it gives me 6, which we just plugged in right there. Okay. All right. The nice thing about this is once we do this in our computer algebra system, we can just swap. We can just hit copy. We can just and there we go. And notice how we get a completely different answer now. Write down that answer. This is 3. Oops. Let's go ahead and do this in blue. This is 3 minus 3, or 16. Are these the same? No, not even close, right? And so that's what we're going to learn here. I'll leave this up for a second before I switch pages. Are these the same? The answer is no. Not even close. So in general, we'll have A is not equal to B, or A times B is not equal to B times A for matrices. And that's like 90% of the time true. Are there matrices where this is true? Yes. Yeah, there's a whole, you gotta hold this. So let's talk about matrix transpositions and vectors. And so we can transpose a matrix, an M by N matrix A is, I wrote this backwards, didn't I? This should be, the transpose of an N by N matrix A is an N by N matrix A. It's written correctly. I probably just copied what the book wrote it. So basically, if I take the transposition, I'm just switching, I switch the columns for the rows and the rows for the columns. And so you just basically switch rows for columns. You just go, you move them all around. Okay. And this one's something that's way easier seen than done. So here, I'll do the first one. So here, if I have A transposition, so it's now, so this is I can do this, right? A 3 by 2. So now it's going to become a 2 by 3. And so the first entry in the first column of the first row, so the first row becomes the first column. The second row becomes the second column. The third row becomes the third column. Okay, so that's the transposition there. For B of T, it'll be the same thing. The first row becomes the first column. The second row becomes the second column. And so that's the transposition of this. Okay, so these are transpose. We'll use these from time to time, not very often. I wouldn't worry too much about it. There's a couple of things. If I take the transpose of transpose, that brings me back to my matrix. If I take the transpose of two, if I add 2 matrix and then take the transpose, the same thing as adding the 2 transposes. If I multiply a scalar and then take the transpose, same thing as taking the transpose and then multiplying by the scalar. Now here's the interesting one. If I multiply 2 matrices and then take the transpose, I switch the order. And then I take the transpose. I switch the order, transpose it, then we'll do the multiplication. You've probably seen something vaguely like this for inverse theorem. If I want to find, for AB, and if I want to take its inverse, I have to take B inverse, and I'm going to multiply it by A inverse. And that's what the inverse of this is because here, if I have B inverse A, B, this will become the identity, and then this will become the identity. And what they call this in upper division math is the shoe sock theorem. It says if you put on your socks first and then your shoes, in order to take it off, you have to take off your shoes first, then take off your socks. It's literally what they call it. And so this is common where you have to switch the order after you do some sort of operation. This is quite common for matrices. Okay. All right, I'm getting a drink. This is a short section. We don't go too, it's not too much into it. The next section is quite long. Oh, someone says you cut in and out. Can't hear anything. Oh, am I have bad internet? Or are you guys good? How's the sound quality? Good, bad? It's good on my. Okay, as long as it's not my end. If it's my end, I can just say hi. We'll start class in 2 minutes again. I'll go reset the internet. Boop. All right, so let's talk about symmetric and skew symmetric matrices. Boop, boop, boop. All right, so a symmetric matrix is if a matrix is its own transpose, then we say it's symmetric. If I take the transpose and it's just negative it, we say that's skew symmetric. And so these are just some names we use for stuff. Let me show you something that's symmetric. Let's do something kind of big. Hi. There we go. Give me a nice big matrix. All right, so let's just say I have 1, 3, 1, 6. And so if I have a 3 here, I need a 3 here, because if I switch these rows and columns, this better be the exact same, right? So if I put a 5 here, that's fine. But if I put a 0 here, a 0 better be here if it's to be symmetric. And if I put a 2 here, a 2 better go here. I can have weird stuff in my matrix like pi. Pi is fine, right? And if I put 4 here, I can have to put a 4 here. And if I have minus the square root of 7 here, that's fine. And so notice here, if I took the transposition of this matrix, I'm going to get the exact same thing. So it's symmetric across. So where's the symmetric? Kind of across the diagonal. So if I have a little diagonal here, this is the same as this, 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 this is the same as this. So that's how you kind of visually look for if it is symmetric, right? Just notice, kind of see if it reflects perfectly across the diagonal. For skew symmetric, let me ask you a question. For skew symmetric, what must be in the diagonals? What must be in the diagonals? Does anyone have a hint what that might be?
Positive and negative numbers on one side.
Yeah, so you can have positive and negative numbers, but what must be in the diagonal is, oh, someone got it. It's in chat.
0.
Yeah, 0, because it has to be, if I take the negative, I have to get back the same thing. The only thing that is negative and I get back the same is 0. Let's just go ahead and put zeros here. Now, if I have a positive 1 here, I'll have a negative 1 here. If I have a 2 here, let's make this one negative. I'll put a positive 2 here. And if I have a 0 here, I need a 0 here. And so notice here, it's just the opposite, but we have to have zeros for it to be a skew symmetric matrix. Okay. Well, that's the end of this section.